Hello and welcome to Quadratic Equations. This video is targeted at Secondary 3 students, which means this is not the first time you're doing quadratic equations because you've done it in Secondary 2. So of course you'll be thinking, what's the difference since we already learned it in Secondary 2? So the difference being that in Secondary 2 you were taught formulas, you were taught steps to follow to find the answers, and if you apply them correctly, you will get your marks. Right? In Secondary 3, that is no longer the case. We need to understand what's going on behind the scenes. How are we getting the answers? Okay. Now, since this is the first video, I think I want to talk about not just quadratic equations, but mathematics in general, right? Mathematics from here on, Secondary 3, Secondary 4, junior college, polytechnic, university, is no longer about memorization. Okay? Because memorization is just not fun. There's too many things to memorize if you want to go and memorize everything, right? So the better way to do this is to understand. Invest a little bit of time, get to know mathematics, and then you don't have to memorize. It becomes a much easier subject. I promise you, you will have fun. So without further ado, let's go into quadratic equations. So if you look at the notes, on the first page, we have a meme, right? Something funny. It says, me using the quadratic formula to find the roots of x squared minus 1 equals to 0. So below, you see a picture of this guy. His name is Bill Gates, right? And what he's doing is he's using a giant ping pong bat to hit a very small ping pong ball, right? And you can see that using the giant ping pong bat is overkill, right? It's just way too big for a ball that small, okay? That is the same case when you're using the quadratic formula. I know students love the quadratic formula because you just have to punch numbers into the calculator and you get the answer. But that is overkill, my friends. Okay? To solve this, x squared minus 1 equals to 0, all you need to know is the difference of squares formula. And oops, sorry, that's x minus 1. And you will know the roots are x plus or minus 1 without pressing anything and in an instant like that. Okay? So, before we talk about quadratic equations, quadratic expressions, have you ever wondered what does the word quadratic mean? Okay, I did. So let me share with you what it means. First of all, English is a Latin-based language. So it's no surprise that the word quadratic comes from the Latin word quadrare, which just means square. So when you're talking about quadratic expressions, quadratic equations, you're talking about square expressions, square equations. Okay? So the difference between expressions and equations, let's just do a quick review because I think most of you know what it is. Now, I have three expressions over here, three quadratic expressions over here. Let's take a look at them. First one is 3x squared plus 5x plus 2. Second one is x squared plus 1. And the third one is 5x squared plus 2x. Okay? And they are all considered to be quadratic because, right, you have a x squared here. In fact, it's 3x squared. But the second one is x squared, 1x squared, and the third one is 5x squared. So as long as you have your x squared term, you're considered quadratic. Remember that quadratic actually just means square, and that's why you must have an x squared term to be considered quadratic. Okay, next, if you look closely at these three expressions, there are some differences between them. Okay, let me tell you what the differences are. In the first one, you can see an x squared term. You can see a term in x, right? Because that's 5x. You can see a constant term, which is 2. Okay? Now, in the second expression, we have a term in x squared. We do not have a term in x, but we have a constant term. That's fine. It is still a quadratic expression. Now, in the last one, it's also different from the second one. You have an x squared term. You have an x term, but you do not have a constant term. That's fine. Right? It's still a quadratic expression because as long as you have your x squared term, you are quadratic. Okay? So we can say that, okay, in general, anything that looks like this, ax squared plus bx plus c is considered to be quadratic as long as a is not 0. Okay? And then you should ask yourself, why? Why can't a be 0? Okay? And I think it should be quite clear, right? If you've been following so far, if a is equal to 0, this whole thing disappears. And what you have left is just bx plus c. And this is not quadratic. In fact, this is linear. right? We learned this in secondary 1, right? It looks something like this, isn't it? The right-hand side, this is linear, isn't it? Yeah, so this is also linear, just that instead of an M, you have a B, C is still C, right? So it is linear, okay? So before I go on to quadratic expressions, quadratic equations, let me just introduce you to the polynomial family, right? We know that linear, right, and quadratic are kind of next to each other, but what are the names of the other polynomials? Now, if you have not heard polynomial by now, let me just explain very quickly what it means. Okay, it's made out of two smaller words, right? Poly just means many, right? Many things. Nomial just means terms, right? So polynomials are expressions that have many terms in them, okay? And we want to look at the different degrees or the different types of polynomials. So over here I have examples, degree 0, degree 1, degree 2, degree 3. Of course, you can go on to 4, 5, 6, and so on, so forth, right? So as long as you have a whole number, yeah, you can have that degree of a polynomial, okay? So looking at constant, what are constant expressions? There you go. Nice and simple, just a constant term, right? Not very interesting. Let's look at linear, right? Linear looks like this. And like I said before, right? This is linear. You should know it's linear. Now, we call this a degree 1 polynomial because the highest power of x in our expression is 1. That's why we call this a degree 1 polynomial. It's linear. Now, as you have guessed, we have already said this many times, right? A quadratic must have an x squared, and it is also the highest power of x in this expression. So we call this a degree 2 polynomial, right? Degree 2. Right? And you should know by now the pattern, right? Degree 3 polynomial means that the highest power of x is 3. It's a degree 3 polynomial. Okay? So again, we need to say that these are generally what our polynomials look like, except that a cannot be 0. A can never be 0. Why? Because when a is 0, say for example, if you look at the linear expression here, when a is 0, this whole thing disappears, and what you have is just a constant term. Right? When a is 0, you get downgraded from a degree 1 to a degree 0 polynomial. Okay, let's look at the quadratic. What happens when a is 0? This thing disappears, you get downgraded to degree 1. Okay, and for cubic, when a is 0, you get downgraded to degree 2. Okay, so now you should be able to understand why a can never be 0 when we are describing polynomials. Okay, now with that, let's move on to quadratic equations. What are equations? I think first of all, let's look at what the word equation is made up of. You can sort of see the word equal here. So when we're talking about equations, really, you must have an equal sign. You must have sort of like a right-hand side over here, accompanied with your expression over here. Yeah. So if you look at the left-hand side, just the left-hand side, that is a quadratic expression. But if you put an equal sign and a value on the right-hand side of it, it becomes a quadratic equation. Okay? And over here, I can say that yes, this is a quadratic equation. How do I check? Well, it's quadratic because the highest power of x is 2. And it's an equation because there's an equal sign, there's a value on the right-hand side. Okay? So yes, this is a quadratic equation. Let's look at another example. Is this a quadratic equation? Well, we have to do some manipulation to find out. What we do is we bring this 10 over to the left-hand side. So it becomes a minus 10. So if we subtract 10 from the left-hand side, it will look like this. X squared plus 5x minus 4 equals to 0. Can we ask ourselves, is this a quadratic equation? Yes, because the highest power of x is 2. Now looking at example number 3. So what we have here is x squared plus 5x plus 6 equals to 5x. Is this a quadratic equation? Well, let's find out by manipulating. Let's bring the 5x over to the left-hand side. So what we have is x squared plus 5x minus 5x. So that becomes 0 plus 6. So what we have is x squared plus 0x plus 6. and that is equal to 0. Is this a quadratic equation? Well, it's quadratic. Does it have an equal sign? Does it have a value on the right hand side? Yes. This is a quadratic equation. Very good. Now let's look at one more example. Just one more, right? And is this a quadratic equation? Let's do a bit of manipulation first. Let's bring this x squared to the left hand side. What we have is x squared minus x squared. So there's no more x squared. We're left with 5x plus 6 equals to 0. Now, is this a quadratic equation? No, right? In fact, it's a linear equation. Yes, so I hope that's clear on what are quadratic expressions and quadratic equations. In summary, right, say if I have something written down here in the bottom right hand side of the screen, right, the one that's underlined in green is a quadratic expression. If we talk about the whole thing, right, the one underlying in blue, the whole thing, that's a quadratic equation. Yeah, quadratic equation, sorry. Okay, so that's the end of the first video. In the next video, we're going to talk about functions, okay? Because this topic is about quadratic equations. Why are we talking about functions? So I hope to see you in the next video. Cheers!